Marco Hahn. So he is sales director of forming business unit at Dieffenbacher. So Marco have a good experience in forming technologies. So he's worldwide technology producer. And he will introduce us in the advanced manufacturing of tailored thermoplastic composites. Okay, so please, Marco.
Okay, perfect. Thank you, Pedro, for your short introduction of myself. So very good afternoon to everyone in Korea, and also very good morning, Pedro. I think you are not in Korea at the moment, so
no.
Just give me a minute to share my screen. I hope you can see it now, and you can also hear me properly. Is it all right?
Okay. Yes. Now in presentation mode.
Okay, perfect. I will give a brief introduction of the company Dieffenbacher itself, because I believe that not every one of you know company Dieffenbacher, and then I will go more into detail about the thermoplastic tape processing and advantages, and then also to the Dieffenbacher so-called tailored blank line, also in combination with thermoforming, and some conclusions at the end of the presentation. So as mentioned, a few words only about company Dieffenbacher. So Dieffenbacher is a machine and plant manufacturer located in Germany. So we are active worldwide, and we have 3 operating business units. One is the so-called business unit Wood, where we supply complete plants for the particle board industry. The other one is the business unit Composites, where I am active in. So for this, we supply completely automated production lines, mainly press lines, to produce fiber reinforced composites out of thermoplastic and thermoset technologies. And the newest business unit within our company is the business unit Recycling, which was also somehow part of your presentation before, Pedro, where we supply complete solutions to recycle different kinds of materials, from wood to plastics to composites and pertaining applications. So Dieffenbacher itself, it's an independent family-owned company, which has been which is on the market since 1873. So we are almost 150 years in operation. We employ worldwide 1,700 employees on our different locations, and we have a turnover of, let's say, 400 million euro turnover every year. And here, to sum up the short company introduction, this shows some typical applications of our business unit Forming. So on the left side, you see our newly developed press system called Fiberpress. Then on the upper side, it's a wet molding line where carbon fiber reinforced components are produced for the BMW 7 series in Germany. And on the lower right side, that's the Fiberforge tape laying system, about which I will talk now a little bit more in detail. So in general, we see that continuous fiber reinforced composites have a large potential in modern automobile, aviation and related applications like sports and leisure industry, especially for structural composites. Tapes itself also have numerous advantages compared to other semi-finished materials like organosheets, for example. By the use of UD tapes for local reinforcements, it's easily possible to place them along the load passes of the components to utilize its full strength potential as well to increase resistance where they really need to carry the load. Unidirectional fiber tapes, they can have a fiber content of up to 50 to 60% by volume to achieve excellent part properties. There are almost no limits with the combination of different fibers, different matrix materials, like starting from polypropylene up to peak pack and other materials. If you process pre-impregnated semi-finished materials, you also have less risk of getting dry fibers within the part, which also causes then mechanical defects. Of course, compared to other technologies, you don't have to handle harmful chemicals, and it's quite a lean process chain. And if you use UD tapes compared to organo sheets, you also do not face undulation within the tapes, which also leads to better technical properties at the end of the day. The Dieffenbacher developed and introduced recently the new state-of-the-art so-called tailored blank line that copes all the requirements and therefore offers benefits of large-scale production in a precise, fast, and economic way for the production of tailored blanks. These are mainly thermoplastic composites. It consists of the main processes like UD tape placement by the Dieffenbacher Fiberforge system to produce tailored blanks, and the consolidation is then done by the Dieffenbacher Fibercon system, which is shown here on the lower side of the chart. The Fiberforge itself is shown here, and it represents the fastest and highly efficient tape placement machine on the market with high accuracy and repeatability. On average, the machine can process approximately one course or one tape every 1.3 seconds, and tapes with a width of 50 to 165 millimeters and the thickness between 0.1 to 0.4 millimeters. Depending on the width and the thickness of the tape, it can process, for example, 208 kilograms per hour based on a PA CF55 tape. And we can create layups near net shape. And another big advantage also to reduce scrap and therefore to increase efficiency is our angular cutting system, where we can adjust a cutting angle between minus to plus 45 degrees. The Fibercon system consolidates then the late blanks by the latest radiation-induced vacuum consolidation technology. Means the blank is consolidated under constant vacuum during the heating and the cooling phase. For example, we can realize a 20 seconds heating and 22 seconds cooling at a 2 millimeters PA6 CF blank. This whole concept leads to improved material performance, so we have no polymer degradation due to evacuation. We have a kind of healing effect of the tape, especially if there are dry areas within the tape, and we can realize and also see then a reduced white content compared to other existing processes. Also, different polymers can be handled, so we also have handled there already polymers like PEEK or PEC on our Fiberforge and Fibercon consolidation unit. And also variable thicknesses can be processed. Also, even within the blank, we can handle different thicknesses in the blank. Here we can see insufficient consolidated and impregnated UD tape. So, for example, we see some areas where we have only dry fibers. We can see high porosity in the tape. We can see surface defect, and this all, of course, leads to a low mechanical performance at the end of the day. And no reproducible heating and forming behavior can be realized. And let's say by typical existing methods, these defects cannot be eliminated, for example, by stem forming. So with the Dieffenbacher consolidation system, which is shown here, we, on the one hand, apply vacuum throughout the whole consolidation process, as already mentioned, and we induce heat by radiation through transparent plates from the top and from the bottom. So compared to other existing consolidation technologies like press consolidation, only a low force is applied to the blank. This also leads at the end of the day to superior fiber alignments, so it means we have no ondulations and low porosities within the blank. So here you can see two examples on the left-hand side. It's a blank consolidated on our FiberCon machine. So we have a porosity of much smaller than 1%, and the fibers are parallel aligned through the blank. And on the right side, it's a reference process of, let's say, existing mainly stem forming consolidation processes where you have a much higher porosity, and you can also experience fiber ondulation due to the applied force during the consolidation process. Of course, this gentle and optimized treatment also has a direct impact of the mechanical properties and performance of the final part. So you can see that we have, on average, 15% higher strength within the plank, and also 25% higher stiffness compared to reference processes. So it means the same plank, the same material, only the different consolidation technology provides this increase in strength and stiffness at the end of the day. Then, when we have then at the end of the day a consolidated fiber blank, we can process this further in different kind of technologies. It can be only thermoformed or purely thermoformed, or we can combine it with long fiber LFTD technology, or we can functionalize it by overmolding or back injection. So this setup here on the right side shows a combination of a Dieffenbacher high-speed press, which you can see on the back side, and it is combined with a so-called bolt-on unit, which you can see in the front side of these pictures. And this setup was installed at the Fraunhofer ICT at Finstal in Berghausen, close to Karlsruhe. And it was used for a public-funded project called MobaHyp. So we also use their different polymers in this setup. So we also process their peak and pack, also within the press, and mainly carbon fiber reinforced composites. So here, for example, you see first of all the layup. So we process their organo sheet in combination with UD tapes. So it was a combination. We had 6 layers of UD tapes combined with the organo sheet, and then this whole setup was consolidated, thermoformed within the press, and then functionalized by this back injection molding process within the closed mold. And also some metal inserts have been also integrated in the mold and then overmolded by this back injection machine. So the main tape had a width of 107 millimeters, and the filling tapes between 18 and 50 millimeters.
Okay, so 5 minutes, please.
Yeah, I'm close to the end. Thank you. So the cycle time for this process for 2 pieces was 78 seconds. Yeah. And at the end of the day, we had then this seed structure produced out of one mold, what we saw earlier. So in summary, we can state that Dieffenbacher can supply the whole system out of one hand and also can support you with our partners like institutes like the Fraunhofer, but also other institutes worldwide to develop components and the industrialization of the full production technology. We believe that also for example, aerospace, continuous thermoplastic fibers have a high potential, and with our systems, we can able to produce high volume production of consolidated blanks. And then in combination with other technologies like thermoforming and back injection, we can create a hybrid lightweight parts and support you in this respect. Here on the last slide, that's I think also important message I would like to pass on to you. We have references all over the world, in North America, in Europe, and also in Asia. So this picture here shows the installation at the Ulsan National Institute, UNIST in South Korea. So also here in your country, we have a system which is sitting there and waiting to be used for you and for your applications. Okay, thank you very much for your time and for your interest. And now I'm open for any questions which may come up. Thank you.
Okay, so thank you, Marco. So there is any question?
Is there any question or comment from the audience on site? No, there is not. Thank you very much.
Okay. No, thank you.
Okay, so Marco, so
Bye-bye.
as we have some time still, so
Okay.
one question from my side. Do you have any example of this technology application in aerospace? Because I think that this application is quite focused on automotive, so by high production rates and very short cycle time. But do you have any example in aerospace?
Yes, we do have. So especially in North America, we have already clients producing parts for the aerospace industry on our machines, like brackets, for example. So one of the references which is open and which we can share is a company called TXV, belonging to Victrex. So they are operating our system for aerospace. And to be honest, yes, in the beginning, our major focus was aerospace, was automotive, but let's say the bigger demand we see really for this technology in the aerospace, and also interesting to know in the sports and leisure industry, to produce, for example, frames for bicycles.
Okay, so I think that in the seats, so as we have to put a lot of seats in the aircraft, so the production rate will be similar to automotive, and so probably it will be an enabler for composite seats.
Yes, exactly. That would be also a very interesting and possible application as well.
Okay, so very interesting presentation, Marco. Thank you very much.
Thank you, Pedro, and
Bye.
good remaining show. Thank you.
Okay, thank you. So now we